Hi, so I think we can get started. My name is Lady Asensio Villoria. I'm a senior lecturer in architecture and urban design at the Melbourne School of Design, University of Melbourne. I'll be hosting the lecture tonight together with David MAH and Djordje STOJANOVIC. And I'll start I would like to begin proceedings by acknowledging the traditional custodians of the land on which we are presenting today, the lands of the Wurundjeri people of the Kulin nations, and to pay our respects to their elders, past, present, and those emerging, and to all Indigenous and Torres Strait Islanders who may be witnessing this presentation. We are extremely pleased to have the chance to introduce Professor Hanif Kara with us tonight. He's a practicing structural engineer and professor in practice of architectural technology at the Graduate School of Design at Harvard University. Previously, he taught at the Architectural Association in London and at KTH in Stockholm. He's the design director and co-founder of AKT2, firm established in 1996, a practice that has won over 350 design awards, including the Riva Sterling Award and the Riva Lubetkin Prize. And his office has delivered some of the most widely published and important architectural and infrastructure projects around the world, and has collaborated with some of the most important architectural offices internationally, as you will see in his presentation today. Hanif's career extends into wider areas of design beyond the structural engineering disciplines. This led him to receiving the UK ACE Engineering Ambassador Award in 2011. He's also the first engineer to be appointed on the steering committee of the highly regarded International Aga Khan Award for Architecture. He's a fellow of the Royal Institute of British Architects, Institute of Civil Engineers, Royal Academy of Engineering, Institute of Structural Engineering, the Royal Society of Arts, and on the Board of Trustees of the Architecture Foundation. Formerly, he was a CAPE commissioner and served as a member of the Design for London Advisory Group to the Mayor of London. And since 2015, he has served as a review panel member of the National Centres of Competence in Research at the ETH in Zurich, and currently sits on the UK National Infrastructure Commission Design Task Force and Expert Advisory Group, and is a member of the HS2 Design Review Panel. He has also authored and edited many academic and professional publications, including the books Design Engineering in 2008, Interdisciplinary Design, New Lessons from Architecture and Engineering in 2012, co-published in this case with Harvard University. Recently, he edited Deliverance of Design, Making, Mending and Revitalizing Structures, and his most recent publications are Design Engineering Refocused and The Architecture of Waste. Please help us in welcoming Hanif Kara tonight with us.
Thank you, Leira, David, and Djordje. It's a little chill down my spine when I hear how you respect the elders of your country. Only Canada and Australia do that. But the other reason is because of seeing you three, knowing you so well in many different ways for many years. So I'm so honored that you have selected me to come and talk. Let me share my screen. So I thought that I would, first of all, try and bring together somehow the 20 years in 45 minutes, in particular difficult because Djordje spent some of the time in the office, so he knows quite a lot of this. Leira has known me for a long time too, so I thought that rather than just present my projects, I would try and get very quickly into a situation where I could update them on what practice, research, and my work has been doing. And I think the Commons is probably the place to start. So the Commons today for me, as a practicing structural engineer and somebody who now for a decade or so has also been teaching, still sits in between value, complexity, and efficiency. What I've always said is that there's a conflict between structural engineering and the way in which technology has actually impacted all of us. So we find ourselves in these in this axis where we're conflicted between what's efficient, what is technologically efficient, and what is value. And the common ground is the cube that I show you there. And what we find is that we sit in that compromise zone trying to balance value, efficiency, and technology all the time. That's become suddenly in the last 6 months even more complicated as a common ground for someone like me. That same cube has turned into a much bigger cube as a consequence of the recent times when the world has shifted, where we can see value now more as a dance. You know, it's no longer a statue. The whole world is going to have to change very quickly. We can see that the whole issue of complexity by the use of AI has gotten bigger, and then the planetary boundaries. So this compromise zone that I call the commons, allowing engineers to operate across disciplines, has gotten really big for us. So I see it as an opportune moment. The other thing that I believe we will get an opportunity now to revise in all these three areas is the common ground of homogenization. So what has been happening over the last 25 years is that we've been doing these four things as engineers, you know, being intelligent, being flying fish, where we try to fly and swim at the same time, architecturally and engineering wise. Sometimes we're modifying ourselves genetically using the tools. And often as engineers, we have too many hands, none of them strong. So I think all of this is going to collapse, and homogenization is going to disappear in the world of engineering in this common space, I hope. And one impact of that homogenization, I've always said, and I repeat with this slide always, is fragmented all of us between academy, practice, building, and our clients. So one hopes that we will now, because of the shock of what's just happened, try to return to the left-hand side, all of us at the same time. In that division, the practice of AKT2, which is the left-hand side of this diagram. This is a diagram that my office, which has a group that tries to help us communicate other ways of thinking about engineering, which Djordje actually led for quite some time when he was in the office. That group is to the right, and the practice or the profession is trying to hang on to discipline, which is the right-hand side. So this bridge between profession and discipline talks backwards to the last three slides I showed. The practice still remains a combination of staunch for-profit engineering office, but also it is still demanding any interdisciplinary action that we can take, in particular right now, in order to drag the profession into the discipline, which I think is not going to be easy, but it is the attempt that we will make. That group does that through, if you flatten the structure and the kind of things they get involved in. So our discipline as AKT2 needs to do all of these things, and we try and invest in this part of the work. So we're not just building and practicing, we're trying to do what I would call research in a very loose sense of academic research as well as practice research that then gets applied to our work. In the meantime, the practice as a project developed its own ecology. You know, we have to keep writing and thinking and saying things in order to move on. Because if we don't do this stuff, we hang on to the profession for too long. So this is the kind of introduction. And for today, I broke it down into potentially three contours. So I was struggling to decide what I can talk about. You know, with having a practice that's been so fortunate to have, you know, 300 or 400 people go through it, and there are 300 or 400 people there. We've been fortunate that each generation has attached us to the disciplines of many contour points. And to try and talk about all of it is pretty difficult. And in fact, it's refreshing to draw it and just, you know, dot it to see how many things we actually deal with. Today, I thought I would talk about three of them. First one is the technology and ecology and the social impact. The second one would be something to do with intersections, direct intersections with academy. And the last one would be the show and tell of a couple of projects. If I go to the first one, I would say that we are being forced for the social tech, let's call it the social, ecological and technological agenda of what we are doing as an engineer or even in education. We're faced with the fascinating situation that non-modernization in many ways is threatening ecology. And what we're finding is that sometimes there's too much eco-hipness or sometimes too much technology. I think we perhaps have to start to switch this a little bit as of now to understand the shift between nature and technique. So rather than abandoning or dominating with conservation, which is what governments are going to do next, we ought to get this balance between modernization and conservation right. Part of that absurdity of modernization that is kicking back on us is our own fault as disciplines, in that we've created absurd and interesting and difficult things just because we can. So society is now beginning to kind of wind down modernity as I would describe it. And we have to be cautious that it doesn't go too far the other way, where we stop building completely. Part of that problem, in order to frame it for today's talk, would be to talk about cities. How do we define cities? And I just wanted to, slogan and some graffiti on you, really, of what I see when people talk about cities. It is so difficult, depending on who you read, who you believe, what book you understand, in terms of who is defining the city. But probably the most difficult one of this is the one I can talk confidently about, which is the smart city, that I find abhorrent at times, because as soon as you attach the word smart to anything, it becomes dumb. And one of those things that I've been finding is this is where the separation between modernity and conservation and how we deal with cities that have a lot of history versus new cities in the global south is really at a conflict at some point, but the global south is going to exceed because it has so much to build. I worry that we're being told that, if we weave sensors into the urban fabric and then troll the social network that has utterances, what we will get with these algorithms is really a city that's on autopilot. My own view is that if technology takes us that far, it is not going to be a smart city. We have to save some of what we have done for the last 4,000 years. Of course, one of the important agendas is the sustainable goals that the UN have set up. And that is a good kind of calibrator in terms of bringing the two extremes of technology and conservation together. And even in that, it is skewed, because behind this slide, what you see is the most vulnerable place in the world, Bangladesh, which has already experiencing all 17 of these problems. Whereas most of us are really still on 11 and 13, trying to deal with climate action and sustainable cities. So I find it very confusing and fuzzy which of these to anchor the work to. So I thought I'd show you several projects that try to, they're not all new, but try to connect to these agendas. The first one is the Mazda Institute of Science and Technology in the desert, a zero carbon city, which was born out of the common ground of academia and a good patron, the country that it was built in, wanted to invest. It is a desert, so it couldn't get any more extreme to try and do something zero carbon. And that doesn't happen without the patron, without the research, and without the people willing to do it. And we were lucky enough to be involved in some of the early discussions of the master plan, but I wanted to share with you the outcome of what largely has been, certainly on Twitter and places, it's been kind of criticized for being a landscape on the moon. But I would say it's been a successful experiment where research has gone to the point of trying to design and build at least a component of a part city. And it is already almost 9 or 10 years old, so it's not new. And that has happened through observing the existing cities of Yemen, which I showed on my first slide, learning from those, how they were built 4,000 years ago, and pushing them through with Foster and Partners, new technology and other consultants. New technology in terms of trying to replicate some of the known things that humanity has been working with for thousands of years, and combining that with real technology and then going on to construction. We got to build one neighborhood effectively of the whole master plan to the original idea of zero carbon. We put in the sun farm and the underground car that's electric, and built one component, which is the center of the city. It is the institute, so it's the MISD, Science and Technology, where all the work is being done on how to develop new green technologies in the future for that region of the Middle East. And this is now fully active. And I just wanted to show you that it didn't require a kind of dumbing down of the architecture by Foster and Partners. You know, it is the best quality of construction you can get. And we use the latest tools, even the instruments or weapons of things like BIM, in order to deliver it. But the most important message is the post-occupancy. So after constructing it, what's important is that the success is shown in going back to see whether the lessons from 4,000 years ago that were applied have made a difference. And this slide shows you the equivalent in the same city, what is happening at our site, where we did enclosed spaces, passive ventilation, thermal mass using the materials we used, against the American dream in a way, the very big streets that are nearby us and the very tall buildings. And at the same time, on the same day, you can save 8 or 9 degrees of centigrade in temperature. So that amount of energy you can save without doing anything, just by putting the architectures of the past through the machine of the present, and then rebuilding that something modern, but something that actually then responds to the climate and the place. I wanted to drop that in as the first type of city that I have certainly been fortunate enough to be engaged with, and show it to you. So there are all sorts of devices in here, and it's still a laboratory. There's literally a laboratory that's measuring, but there are indicators that tell you when you're using too much energy. And we have the old supreme features of building in the desert, with courtyards, buildings close to each other, natural ventilation, so on and so forth. The second example in that socio-technological, ecological history is what I call the pop-up city. And Olympics probably provide a kind of another fast moment when you can look at what cities could do very quickly, as opposed to the ancient one that I showed. In this one, we were fortunate to build, many of the things, and we were at the right time in the right place to get appointed for many projects. That ranged from the legacy projects of a school for the new community of Stratford to the power station. So we're not, as an engineer, nor as thinkers or as practitioners, concerned about type, but what we're concerned about is being able to work across cities in these different functions of buildings that make a city. In this case, I'm showing a school, which is now fully active with nearly 1,200 students, and then the power station that powers post-Olympic. Both of these were built before the Olympics, and then through the Olympics, they take shape in a way. I wanted to focus in on one particular technological advancement that took place on that project, which is what was called the Carpenters Lock Bridge. This was the main central bridge into the Olympics. There were 46 bridges, and only one was a design competition. So this is the message. It was an interdisciplinary invitation. Architect and engineer had to take part as a pair. So that separation and fragmentation of the discipline that I talked about was eroded by prescription. And sadly, the other 45 got built by engineers. But at least there was a movement that allowed to show what happens when you put the disciplines together. And Hennigan and Peng architects were the lead consultant on this, with us supporting them through a competition. And the master plan in the air looks like this for the whole Olympics. And basically 60,000 people an hour were going to walk across this bridge only for 17 days. But then it was going to live 100 years after that. So our design, the technology, and also the formal idea was to really compete as architect engineer with this, the short list is here, compete at the highest level to redefine what architects engineers can do when we work on a bridge. This is not to say big engineers can't do bridges, but it is to say that if a bridge is seen as something more than a bridge, as Cedric Price said, then you need all the disciplines, and that includes art. So we were kind of able to predict what others would do. You know, either the engineer would dominate or a particular architect. And we came up with a solution that I feel responded much better and won and built it. So during the Olympics, it was a land bridge with an excavation underneath it, which will be exposing an arena later on when we remove the Olympics. And Shifu Peng and his partner basically came up with the idea that we could build it as an Olympic motif during the Olympics, using recycled trainers, and create these two land bridges. And the Z shape in the middle, which is the supreme feature of what is left behind after the Olympics, would be a piece of jewelry, but it would still be a bridge. The idea was really to build the bridge, the land bridge, with temporary materials from the rest of the Olympics. So for the 17 days, to aim at the sustainable idea of recycling materials rather than just build it and then destroy the materials that would disappear after 17 days. We would invest in temporality, in temporal materials that could be reused from there, whilst the jewel would be made redundant during the Olympics, and we would build it with the best quality stainless steel. So during the post the Olympics, it would be looking like this, and during the Olympics, it would look like that. So the whole idea was really to construct something that saw the 100 years and the 17 days at the same time with the most incredible geometry. And that requires the kind of tools that Part work with, and people like Hennig and Peng and that generation of architects use on a daily basis. So I just wanted to flick through that very quickly to say that the complexity structurally was really in trying to span the long span in the thinnest possible way, because the boats can still go underneath that span. So at the middle of the bridge, in the Z part of it, we had the shallowest bit. And the architect-engineer conversation that Corbusier started, the separation of the two became quite important. The architect assumed that it will be something that looks like what's on the left. This is his diagram. And we had to remind him that in order to build it quickly, fast, and so on, it would look more like something on the right, not a surface system, but a line structural system, because we needed to deal with the kind of the problems of dynamics in the middle of our bridge. I don't know if you can see the bridge moving, but I'm not sure. So it basically, the middle of the span moves quite a lot. Here is the construction, and here is the 2 days in which it was assembled. So the discussion between architect engineer became, still is a problem, even after we built it, that we keep arguing about whether it was a misunderstanding or a separation of disciplines, despite the fact that we work together. What's nice is that it did get built. And if you go, it was popular during the Olympics. And if you go there today, it's still a superbly popular place. So this is during the Olympics. Today, it's one of the most popular Pokemon spots, because it's become a place for people to visit. It's not destroyed. So there's a pride in what was built over there. This is during the Olympics, so this is what I was trying to describe would happen then. The second ecological type, I guess, in there is the thing that's going on in the whole of Western Europe and will come to you one day, which is what people are describing adaptive reuse, particularly of old infrastructures. And I wanted to show Birmingham New Street very quickly. This was, again, an international competition, a 1940s built railway station with a shopping mall on top of it. This looked like this, and it's because of where it was. Modernity was kind of, the shopping mall over a station was dying. There was nobody in there, yet the railway had to be protected. The city of Birmingham needed to do something, because this is really the most important station after King's Cross and Euston in London, because it takes all the traffic to the north. We were very fortunate to work with FOA on this, and we produced a very interesting design. Can I just check, are you seeing this as a movie or as a still image? Movie?
It is an image, not a movie.
Okay, all right. My movies are not working for you for some reason. Okay, so I will go faster then in that case. The material was not sort of Gary-like. It was beyond Bilbao, proposed by FOA, which was to save the station, keep it operational, but introduce a skin that would create in the city new light, new reflection, new place, new security. And what you see is this, the restrictions are enormous. In the trains go here, every 4 minutes there's a train going under here. We had to construct something that would allow us to kind of map the sun computationally and understand how this skin would eventually reflect not into people's eyes, but the city, and also how it would then demand a structural system that could be adapted and adapt the old structure. So the big moves we made was cut a big hole in the middle of the station without killing people, introduced a new atrium, brought light into it, and put this wonderful skin. So the city is alive. When the trains go through, you still see reflections of the train itself going through. But you also see in the city a light, even during the sun setting and the sun rising. So it livens up the whole of the city. So it's not a simple case of just adapting a structure, but taking the use of the structure, applying new tools to it to see what redundancy was in it, and then saying how far can we push that without taking it out and stopping the trains. Inside, we put this huge roof with supporting ETFE. I think it has had something like 6 million visitors, which is 4 or 5 times the population, or people go through it, of the city. It's been very popular. The retail is now flying and it's really doing well, although COVID has had some impact. So there is that second type. There was the conserved city and the lessons from there, from the deserts. There was the Olympic city, and then there is the common city that I call in. This is Berlin, Paris. A lot of the Western European cities are going through this. How do we save the infrastructure and do something? In that kind of stream, buildings are also becoming very important, in that we're finding that particularly London, which has a lot of treasures. This is Surinam's American embassy. So using the tools from Birmingham New Street, we're going back in looking at this with David Chipperfield. So the fortunate thing for us is we're working with 2 great architects, Surinam's original building and David Chipperfield, which was a competition, to look at how we can take this classic listed building and then do something to it. So we're going to convert it into a hotel stroke museum in the center in Grosvenor Square in London. It's on site right now by inserting several basements underneath it, but taking as little out of the original design and adding to the top of it again. So these tools and this approach of modernizing with care is actually allowing certainly the ancient or the medieval or even the kind of 20th century city buildings to have a new life. It doesn't mean all buildings need to be saved. The other building I show you quickly, which is just finished, is Regent's Crescent in London, which is a John Nash 1800s classic. Again, we have just redone this. It was a grade 1 listed, and the kind of convincing of the city and convincing of government and heritage people that we were capable of actually, as architects and engineers, taking some of the treasures of cities and applying a new contemporary twist to it. Because the original facade, which had no joints in it, masonry facade, was not original. During the bomb damage, it had been repaired and replaced. So we were allowed to redo the whole facade using lime mortar and construct a completely new crescent in there. So historical buildings like that. The last of those is really extending tall buildings. So we've done 12 stories on top of a 13-story building at the South Bank in London, where we're finding old codes, even from the 60s, that are allowing us opportunity with some cleverness to add and redo some of these towers already. We're doing 3 or 4 of these projects. So I wanted to leave that first group at that level, just to tell you that, you know, in that group, technology, conservation, adaptation, and sustainability are coming together, and we're doing some interesting stuff. The second chapter I wanted to talk about is the intersections with academy. And with Leira, for 3 years, we were fortunate enough to look at waste, which is an urban design problem, which we arrived at because largely because Sweden has almost 0 landfill, and the USA has 60 or 70% landfill. So this circular economy conversation about how do we get rid of our waste was an interest to me and Leira, and we managed to get sponsorship to do a large piece of research. But the alibi for this research really was to raise the profile of the architect in the world of engineering, because in infrastructure project, we were generally finding that engineers just did it as a machine. There was little or no design. So this academic research at Harvard, which was 3 years of it, did quite a good piece of work saying, you know, if you do choose not to landfill, one of your solutions is to build energy for waste power stations, which are not the greenest, but they are close to the greenest. And you can put them in the middle of your city, so you don't have to drive trucks everywhere and so on. And we were kind of fortunate because I had been with my practice very successfully, won a competition in Copenhagen with Bjarke Ingels, who had, his group had also been exploring this idea, and Copenhagen had done what I call the 80-20 rule on one of their power stations. They invited a team to work with 20% of the design of the new power station, energy to waste in Copenhagen. By that I mean 80% of these buildings is done by an engineer. They don't let you near it, the client or anybody. It's just a photocopy of the last energy for waste. So what does design do in that situation? How does it connect with academe? So by bringing the conversation into academy and then rolling it back out into practice, then pulling it back into discipline, here you see Big's idea of making a place, thinking about health, thinking about wealth, thinking about new modes of actually understanding these cathedrals, let's call it, and we were successful. It's now history. It's on TV adverts. It's become an icon. House prices around a waste power station have gone up 10 to 20%, which is unheard of. So the message of that research is really societal and not just ours in a way. That's one of the reasons why we intersect with academy, to find some common, hopefully common linkages between discipline and profession. The second group in there is really with office structures, office design, who are Ljubljana-based architects that also are the same generation as Djordje, Leira, and David. And they've been doing a lot of work on extreme environments. And I just wanted to show you one studio we did at Harvard. They set a script which was about building on a very complex mountain in Ljubljana, ran a very quick studio. So this was a design build type of studio, 14 weeks. And one of the ideas was to go into an extreme environment and hopefully build something, a shelter. So the outcome was to select one piece of work and build it on top of a mountain, Skuta, in near Lake Bled in Ljubljana, one of the students' projects. And I have to say, one of the ambitions was to lift it in with drones to replace the donkey and use drones in a positive way. We didn't achieve that. It's a pity you're not seeing it because it is a movie. But what happens is that that kind of shelter has now become, on the left-hand side, also a similar experiment was carried out to allow us to do an extreme environment as a courtyard in London, in our office. So with the same architect in parallel, we were looking at tight space making, spaces for isolation before COVID for single people. And we made a little pod that's on the left. So basically we're looking at miniaturizing and modularizing and building fast these projects that are shelter in extreme conditions. I'm sorry, the movies are playing on my other screen. I don't know how to shift it, but that's fine. The third of these academy intersections is the universal building, which again connects back to ideas in London. We ran a studio with Harvard again, with Offerdo Moynihan Morris as a practice. So we always teach with architects. And we looked at the next district that's going to be developed in London called Canada Water with British Land. And what we managed to do there is really bring the students and talk about London, to let them live in the white collar factory, and then have these 4 quadrants of what I call people shaping London, you know, from specialized people to integrate, those who integrate architecture, architects and non-architects. Give a seminar continuously on a weekly basis that discusses the future of Canada Water, how we might make a new quarter in the city of London. And these seminars were running in parallel with geographers, with sustainability experts, with the LSE, or what is the future of a Western city at least. And then we gave the students plots that were just dividing a car park into 12 plots, and they were each to work on a plot, but not speak to each other. The concept being that they would come up with a universal building to some extent, but it would be on that site, and they wouldn't be allowed to talk to their neighbors to begin with. Of course, this goes back to the whole idea of exquisite corpse and how cities organically grow, and London is a classic example from medieval to now. And what you see is that it's, you know, the next project, the next architect, the next style is not necessarily constrained by the last project, but it has to be informed by the history of what was happened. And it's not a linear model. The other condition on them was that they had to be able to make this on a weekly basis. They were making models weekly, no drawings to begin with, and eventually would be able to pack it into this little pack and then transport it to Boston for the final review. You can't see the final product because my movie's not playing, but I can tell you that ultimately we managed to make 14 projects and take them back to Boston. As a kind of question mark on whether universal exists, we can come back to that in the conversation. The current one on research and intersections is about material research. And here with Jennifer Bonner, we got interested very much in taking a particular material, cross-laminated timber, which is big in Australia now, through the work we've done on a couple of projects, including this house that won many awards with Frederick Ludwig of Acme, and also some cross-laminated timber ground scrapers we did with Richard Rogers. But more importantly, Jennifer and I had been talking to each other for quite some time about her work, her idea of flat surfaces, and a particular house that we built together, which is called House Gables in CLT in Atlanta. That experience in Atlanta of building that house had really been problematic because the atmosphere in the US was not accommodating of the ambition of this kind of material. So we ran a studio this spring, gone just now, which was basically looking at the impact of mass timber in Scandinavia, its effect, and then looking at that and saying, okay, what if we try to take some of that as a studio, a collaboration between engineer, architect, technology and material, then discipline and profession, and also encouraging new young thinkers to rethink CLT as a surface material. Part of that involved going to northern Sweden, Martensons, a small factory that makes cross-laminated timber for a week, just before lockdown. And then we were lucky enough to go and see a 70-floor CLT building that's being built there, already. So the students were immediately converted into a kind of almost a CLT cult in a way to help produce the work of the studio. We looked at two scales, a high rise, which effectively was one we'd seen, 72 meters, and setting an ambition of about 120 meters as a maximum in CLT. And we looked at the house scale in one semester. The houses that were produced for South Carolina as our site, as you can see, were for 10 people. And again, we did not have COVID at the beginning of this semester. We finished the first project very quickly and then moved straight into online learning. So this was the last image, and they're not physical models, of the houses that were produced. And then the rest of the semester was finished with the high rise in CLT over time with this product eventually. Now, again, I can't show you the movies because my thing is flying. My movies aren't working for some reason. But what I can say to you is that the research that was done, it is on Instagram. If you check GSD Mass Timber, you'll see quite a lot of these projects. But as we suspected, the students came up with new questions about CLT at both scales, to the point where it draws in the architect and the engineer much earlier. So rather than imagining this material only as an industrial product and the realm of industry and industrialists and investors, how can designers bring it back? Because ecologically, this material is not going to go away. So we go on to the last section, which is engineering types. I wanted to just drop this in because this is the show and tell bit. I'm going to finish with this group of projects. The first is really office type, which even since these slides were made, as you all know, has changed. This is the white collar factory that we've been working on office design and the future of workspace for many years, particularly with AHMM architects. And we live in one of our own buildings, the white collar factory, that was until recently kind of the poster person for how to work in a creative space, how to create a creative space and naturally ventilated, passive ventilation, exposed concrete, the warehouse concept, which was partly born from another project we'd done previously with the same office. So icon, modernity, you know, the whole idea of concrete and how you can expose it materially was brought into how we can imagine these spaces to be museums, workspaces, living spaces, and factories all in the same building. Unfortunately for us, we've been grabbed by that industry. So we've been lucky enough to work for the best clients that have been building, certainly in London. So this is Bloomberg's headquarters with the Foster and Partners, which is now finished. A classic workspace by a patron who wanted to leave a legacy, an architect who also wants to do the best building he possibly can, having influenced all of us for so long. But the site is probably as difficult as it gets. It's right in the middle of the center of the square mile. So effectively St. Paul's as the conservation icon, you know, in terms of height, but also the infrastructure underneath the site. Because it's a Victorian site, we have all the sewers, all the railways going underneath this island. And the problems of what we have created as engineers was kind of creating for the city the risk that, you know, high quality land could not be developed on unless we went for some interesting tools in the way workspace could be made. And to make something like this, you need complete investment by the client and the architect and everybody, including the structural engineer. So this is the master plan, and this is the built object, which won the Sterling Prize not long ago for us as a team. A wonderful, simple office typology to some extent, but 3 or 4 very clever things. One of them is the circulation space. And the way Bloomberg's work is people come into the reception at ground level, go to the top first, where they have a pantry, where they manage to converse and mix and talk before they go to their workstation, which are lower down. So the common ground is at the roof level, where there is serendipity, conversation, deal making, and some fun and healthy foods. A lot of instruments were used to model for example, the forensic modeling by Foster, again, taking the work all the way back to Mazda, in terms of air quality, because we wanted to make something that will be taking the air in, but it can't right now because the air quality isn't good enough. So how could we design a facade that can be open in the future? For which the architects and the M&E engineer and structural engineer need to work together in order to be able to design, very finely how this will work. And the facade is probably the most interesting architectural part. And I have to say, when you go to the building, you will see that it will be there for 100 years. That was one of the kind of ambitions, made beautifully, but formally it is to break the space so that what is 3 or 4 floors looks like 1 floor from the outside. So large building actually doesn't feel out of place in that location, which is the architect's strength. But we've reconnected all of the medieval streets on this site, and we've kind of put a public space at the ground level with the normal restaurants and so on. The facade, breathable facade, is highly tuned in that it is bespoke, made fins that can open automatically to let in the air. Lots of testing done, lots of prototyping. So this is the level of detail I wanted to show, because I don't want to leave you with the impression that you just come up with concepts and draw and then it happens. I think it's important to say that if we are going to find profit in the difficult times we're going to come across now, the disciplines, instead of that fragmented issue between construction or architect and engineer, academy and practice, if we all come together, we've also got to be able to see the things from the other person's view. Here, how we would make something as fine as this had to be tested physically. But probably the most difficult part of the project is we found Roman London underneath our site, not knowingly. We didn't know it was there because it's been buried by other people. We had some suspicion. And that was a major, it was the Pompeii, basically, a major kind of story of London reincarnated, and the architects and the clients were very pleased to donate a lot of these artifacts to the museum, but also recreate a small part of it inside our building so visitors can go and see what was the Roman site. But this is what I wanted to show you as an engineer, because the gray is what is already there. This site had been developed since 1964 times. So the archaeology of the engineer was harder than the archaeology of the Romans, in the sense that we could only put in a certain form, a certain type of building on this site, with some very clever soil structure interaction modeling of how you could reinforce the ground to take the weight of this building that sits on top. Inside, I said that there was a couple of special features. One of them is the reception area, which is a beautiful piece of timber with a kind of volute geometry that allows you to come in and sucks you up with the geometry made out of timber. And you walk up this ramp or walk down this ramp, so you can go up on a lift to the pantry if you want. And this allows, again, a really nice way to circulate to your desk after you've been to the pantry, but also meet, bump into people, talk to people, and then at the top also enjoy what is perceived to be the most beautiful view of London's architecture, which is St. Paul's. So I just wanted to fly through this and show it to you. We did other things. On the left is we exposed underground rivers that have been buried as art. In the middle is an art exhibition that now takes place. They change it every quarter. So different artists actually occupy the space. This is, for example, raising awareness of melting ice done last summer, just as an art piece, just to kind of draw attention to the ecology. So within that type, I wanted to say something about, what is the ambition of Zen soulfulness, which is, what we're all trying to do. And it come to light even more now that we're all working from home, the importance of health and the importance of your workspace, both at work and at home. And I was fortunate enough, when we were pitching for Google's projects, to read Eric Schmidt, who used to be the CEO of Google, write a book that said, you know, what makes Google? And core of that book is basically you have to be people-centric. So a lot of these important clients have already been baking in the importance of the body and the human in terms of how you build a future workspace, what will be the future of life. So I'm fortunate in that Zen soulfulness in workspace started earlier. And I think with an added poignancy now of how we will deal with the pandemic, this is an area of work that will only grow. So this is Bjarke Ingels and Thomas Heatherwick, Google San Francisco, where the idea was really to create a global scale or large scale environment with the dome, to a human scale, which is where people work, to the habitat connected to the nature, and the four kind of streams of work, you know, building something like this after you've designed it, using the digital analog techniques, including how you make something like this, and then the fabrication, you know, do we automate some of the construction so we can reassemble this building quickly? And then what do we cover it with to maintain the atmosphere such that it is like being outside in California, yet it's a filter. So there's a lot of form finding work done, a lot of tools, including ponding on the roof. And I just, you know, give a nod to our computation group here, because a lot of this work is impossible without what I mentioned earlier, the non-professional structural engineers in the office, who I say are broader designers and actually raising these questions and computationally being able to solve some of them. Even with low tech, what looks like high tech, you know, how do you reassemble something like this? So that building is on site. If you go on YouTube, you will see this video. It's almost finished. This was actually a bit from a video. So we will be opening it sometime next year, almost as it was conceived by Bjarke Ingels and Thomas Heatherwick. The last of these is Slow Burn City. You know, in a way, King's Cross is that. So after Olympics, you have the buildings that I described, and then you have districts where King's Cross is the latest district. And again, AKT are lucky that we worked on 12 of these buildings. But the one I wanted to show you quickly is how that connects back to Google, in that they took one of those plots to make a 400-meter long building now with the same architects, Bjarke Ingels and Thomas Heatherwick, the longest 400-meter long. So if you stand this up, it's taller than the Shard, with a new public park on the roof. And again, under construction right now. You can't see the video, unfortunately, but I can tell you that this is the whole video taken about 6 weeks ago of the CLT floor that we're building. I have two more, maybe 2.5 projects to show you. I had to show you a tower, and without the movies, it won't be as effective, but we've been very fortunate again to work in Canary Wharf, where there are lots of towers. It's our tower district, but this time it was to build a new icon, a residential tower with Herzog de Meuron and Canary Wharf Group. And as you can see quite clearly, the characterization and identity of a cylinder was something that is alien to this district. And the reinvention of a type, you know, what is the residential type for vertical living in the context of London, and this affects many of your cities, was really the mark of success and the supreme architecture, in my opinion, because it may look like the car parks in Chicago as a cylinder. There are many cylinder types, but it is highly complex in terms of the different typologies that occupy the height of this building. So there is a transformation taking place, which is also structural, as you go up, building lofts, clusters, amenities, bay windows, different types up the building, which is being made possible with the tools. So, you know, with some of our tools, we're able to combine stability systems between cores and outriggers. Many of you will understand that. And use, rather than only one type, change the typology and merge the typology up and down a building in order to deliver some of the things that these sorts of architects are doing. So This is a typical plan, but I can assure you the columns that you see in the core stays the constant, but the columns move up and along the plan in order to accommodate different types. And also the spiraling of the flats. So the windows are never at the same place in order to allow a kind of principal, let's say, privacy to an extent. Again, looking also at the urban scale, the impact of the bioclimatic events that will take place, and also wind after we've built, during our construction, was all modeled, which are things we're able to do these days. Again, it's constructed and looks pretty amazing, I think, nearly finished. And there you get a feel for the outcome, which is everyone has a unique view, everyone is private, yet the structural system, through those things that I mentioned, overlaps between types of structure in order to deliver a new cylinder that is really driven by a new way of living vertically. And the icon is such that you see it from the district itself. It offers a new identity to what is the only residential block, let's say, in a largely office environment. So immediately it's announcing itself beautifully and then landing into it. I want to show you, I have to show you at least one Zaha Hadid building. Sadly, my movies don't allow it, but this is generally in Milan, but I really wanted to show you where we are. We did several changes to this type, as I showed you. The Herzog de Meuron move structurally slightly different from what everyone's used to, extrusions. But Zahas have also been doing several of these. The case in point here is taking Iraq and the central bank there, and starting with the core as a building, so a box that is secure and made of concrete, then splitting it up as you go up the building and rotating the columns, again, to make something that faces the wind. So basically we're splitting the core and dividing it up to rotate it so that you can get views lighter. It becomes lighter and lighter as you go up the building. So as a formal architect engineer move, this is not extrusion. You know, it is parametric to an extent, or it is using the latest tools and material techniques in order to deliver a new high-rise, which is currently on site. I don't want to talk a lot about this, again, because if you want to see it, Ed Tabuzi did a fantastic lecture in Fabricate last week in detail. But I wanted to mention it because without doing the kind of towers that I showed you, I don't think we would have been able to do the vessel, because the vessel is about not only stacking a simple brick into a complex form, but it's about taking the technology of human comfort. You know, what is it that people get scared of when the building moves, and applying that to a public space. So all of the work on this building really was an inverted form where vibration is the key. You know, when you get one person on here at the top, or 10 people, or when it's really full with 240 people or 1,800 people a day, how much does it move? And that wouldn't be possible without having done some of the vibration calculations on the towers that I showed you earlier. This is a movie on YouTube, so you can find it. I'm finishing now. I wanted to just show the last project, second last project, which is the Serpentine Pavilion, and say that, you know, technology, ecology, academia, all of these things sometimes comes together by luck. So being asked to do something in London for Serpentine and being challenged to do something different from what had been done very well 12 times, partly involved working with Bjarke Ingels in New York, his Copenhagen office, competing for this project, and then building the Serpentine Pavilion in probably one of the most complex ways you can imagine. And this slide shows you the left-hand side is the imagination of a new brick type. In the middle is the forensics of how we might make it. And to the right is the rendering of what it might do to the space. So that can only happen through all of the things I've been talking about, through splitting the processes and automating with an amount of artificial intelligence, an amount of scripting, so that we can do it at pace, we can do it fast across countries, across timelines, and also rethinking Platonic forces in a way, you know, where we divide things to beams, columns, and so on. What happens when there's a complex form like this, where it's difficult to define anything as a wall or a column or a slab? And quite a lot of that can only be done through the work that I've shown you. I'm just flying through it. This was the ambition achieved, finished, again, made out of reinforced plastic boxes, the size of a coffin. And this was transportable. So the ecological story is it was in Vancouver last year, for those of you who are interested in it, and it will keep moving as a pavilion. So it is recycled in that sense. The most advanced plastics to make an English brick, a new version, but I'm not sure our community will accept it. I want to finish, definitely finish with Lebanon, because I was very sad and tragically hurt by the fact that this building, which is the souk, burned down last week, partly. So I wanted to really say that, you know, all of these things don't have to be in the West. This is an adapted building, 3-story car park underneath us. With Zaha Hadid, we built a new shopping center. And this video that you can find on by Ahmed Shandir, who's somebody that lent me the video. You see it just before it was on fire last week. It went viral last week when it caught fire. So I'm at the end. All I want to say is, all I've been trying to do is connect science and architecture through this conversation, and build a common bridge across us so we can have a conversation about it. And I apologize if the buildings were too familiar, but I can tell you the script was specifically designed to work with you. That's it. Thank you.
Thank you very much, Hanif. It was a great presentation. I think we are getting some questions already coming from the audience, and please, any other questions that you might have, put them in the Q&A, and Djordje, David, and I will communicate them to Hanif. Maybe
did it make sense? Because I was a little uncomfortable with my movies, but I hope I managed to get the message across.
No, it was great.
It was great. Yes, it was clear.
So maybe, I mean, since there's already 2 questions up, we can ask one, and then all 3 of us can also do little interventions. We can have a little chat, but we'll start with Don. So Don has a question. So you've spoke eloquently about working with architects and working collaboratively between architecture and structural engineering. Could you speak about how you interface with all other consultant inputs, especially with environmental services as well as landscape? How do you negotiate the architectural, structural, and environmental services inputs and others as a fully collaborative process to deal with the full range of sustainable responses for the range of projects you've worked on?
Yeah. No, I think this is quite a clear debate, and it is very old. And I would say that Corbusier killed us all by allowing that separation. So the way I try to bring it all back, I admire the man, and I love the fact that he created a whole new century of architects. But I do feel that my initial diagram of collaboration takes it back to the concept has to have a leader. So when I collaborate with other designers, I have to come from the position of an empathetic engineer, which Djordje knows quite a lot. It is not easy to work with Zaha Hadid and David Chipperfield on the same day as a structural engineer. You know the 2 architects are different, but I can tell you that if they could both tell you, you know, they wouldn't see the difference in the way we operate. And equally, collaborating with other consultants, I think that kind of architect with our type of engineering, which responds to the position of the architect in an empathetic way, we have taste, but we never show it. Then we also, by making their work possible, let's say, and our work lift up because of the question they asked, we also do the same to other consultants. So we're quite demanding and pushy. And I don't like, Don, I don't like the word collaboration. I really don't. I use it because everybody understands it. I think you have to be first amongst equals. So the way it seems to work best is when you, in your own field as an architect, or in our case as a structural engineer, as a bottom line are technically supreme and technically confident and capable. And AKT as a practice in terms of total design, which is an Arab model, a very old Arab model, have withdrawn and surrendered that idea of Calatrava-ism, or I don't know, all these signature engineers, in that we felt that the building and the place and the client is important. If we make the architects speak that language to the client, we benefit as a discipline and as a profession. And other consultants have to fall with that. So we're very well known for being able to articulate positions that get the right type of other consultants to join us in that endeavor. So you have to be pretty competent as an environmental engineer. And my diagrams of all hands together, you know, the octopus is kind of a pop at that model of multidisciplinarity compared to interdiscipline. Multidisciplinarity has the risk of bringing B-level consultants all together at the same time, giving you a homogenized average solution, which 90% of the time works fine. But if you really want to invent and face the challenge that society is facing in ecological terms and technological terms, you have to be a specialist in one field and pretty good at the other fields. So what we find in direct response is that I know what the three best environmental engineers look like when we work with them. And I know which one tells how many lies and truths. And they know I know. So the collaboration happens without pointing that out, because they're in the face of these architects that I mentioned, who are also like us, attuned to being sold that collaborative model, and are not used to, kind of made themselves out of that model in order to invent and do the incredible projects. And I have to acknowledge your wonderful project from many years ago at the AA. So I know that you understand that, but my point on that is it's an old-fashioned response. I have to be technically brilliant, and so do my engineers, in order to be able to tell the M&E engineer, if you're not good enough, we're going to make you look bad. And it seems to work.
Hanif, I wanted to ask a lot of things, but I'll try to put it in one question. Firstly, thank you very much for the very inspiring lecture. I think it was really impressive. The volume and the scope of work that you guys are doing is just amazing. And my question is a historical perspective question. Sort of, I'd like to hear from your point of view the way that AKT has expanded over time. And I think it would be a very big privilege to hear about your beginnings at the turn of the century, about London, your ties with the Architectural Association, and that could tap into conversation about the relationship between research and practice, and many things that are very much related to your office.
Yeah, no, thank you for that question. So in '96, when I, with Albert and Robin, started AKT, it was through a frustration of a similar recession, in that basically there was a recession that was going to kill the industry. And some of us said, we don't want to leave the industry. We're young. We want to create new practice. What does it need to do? And we made two clear distinctions. One was, we need to tell people how to make things and how to build things. And by people, we mean architects, because that's a big failing. They are completely in difficult terrain. Whenever a contractor comes on board, the client assumes the contractor knows best. And the second thing we thought was education, in that scientific research was elitist. It still is. It doesn't even accept good engineers like me, because we're too professional and too practical. Architectural research doesn't have a completeness to it, and allows many disciplines to come in, partly because of its own insecurity. So we wanted to connect with education, and rather than go to school at Imperial, I went to the AA, as you know, and you all guys know, and that blew my mind, because it was the first time, believe it or not, even 26 years ago, I saw 3D drawing. Engineers didn't understand render or 3D even then. So for us, that beginning was golden, in that we were at the right place and the AA was fantastic for that. We met young talents that were rethinking their own discipline, but more important than anything, we're able to communicate what we do to our cities and what we leave behind, which is not always easy for architects or for engineers. And I felt that we had to maintain that second arm of always teaching. So today, you know, we all teach, many of us at the RCA, AA, we all don't let go of that because new questions are asked, as you saw. We're also all largely even engaged with our own institutions in trying to modify it to be more inclusive. That's a big game and it will be difficult, but it's something we're trying. But we also went to a point where we became too successful after 10 years of practice and in demand, because we were also popular with contractors who were saying, translate and develop, translate what the architect wants. We want the architect, but we don't know what he wants. We don't understand what he wants. So can you help us? Because we want his building or her building. And we became too popular. And at that point, we felt that we couldn't cope because we were going global. And we sold the practice, which is quite an incredible story. But I'm not ashamed, because I think the entrepreneurial edge was really, how can we, rather than go global, how can we from London as a local model actually do international work? That was the idea. Of course, there was then another recession, the crash, you know, and the company keeps transforming. You know, today we are part of a bigger group, which is Tyrrens in Sweden, but also Holcim Moran in the UK. But AKT maintains its identity as a practice, design-led and discipline-led, but professional. So it does still fight to invest in not profit only job by job, but actually staunch profit as a totality in terms of how many awards can we win, who can find the next new idea, who can work on the best buildings. So there's a lot of competitiveness in there. And that, I think, wouldn't happen, Djordje, unless we had contact with people like you. You know, you kind of created a lot of the work in part, even assembled it for us when you were directing that to a level that we couldn't ourselves. And that is carried on. You know, people who benefited from that, the next generations, have now kind of made something different out of it. We have a facade group, you know, which we don't call it facade, we call it envelope, because we, again, don't like giving away the thin slice of the skin. So I think all those areas are both deliberate in terms of entrepreneurship and surviving as a practice, but are also interests in continuing the passion of engineering and feeding those who are passionate about their own work. And I think the practice continues in that vein. And then these kind of talks make you rethink, because even when I was planning this, I thought I can't just deliver, you know, I do one a week, but I don't deliver the same thing. These guys know me. Australia doesn't really know me, although I've been there. And there will be a small group of people that have never heard what we think. So I have to rethink what the practice is and how we deliver what we're doing without just doing a kind of, here's 50 show and tell projects. I think we've got past that. I hope that answered your question.
So there's quite a few questions coming in from fellow faculty as well as the public. So Brendan McNiven and Alex Felsen have a question, but I thought I'd slip one in before we head into there. So, I mean, it's, you know, it's pretty, you can read between the lines, but it's, you know, clear that you know, when you engage in your practice and your research, you know, particularly the research, like you said, you chose not to go to Imperial College, but to go to the AA. And whenever you do a kind of large research project, you always partner with an architect. So it's clear that your research, like on things like CLT and waste to energy, isn't driven by looking for, like, say, optimizations or efficiencies, or necessarily looking for things that could be standardized knowledge somehow. I guess, you know, your choice to kind of engage this larger, you know, these partners in your design and research, what is the motivation for you? Like, what is it? It's invention, or what is it?
No, it is in part innovation. So that first slide that shows the three axes of efficiency, value, and technology, you know, those that Leila knows this well, because she spent so much time conversing about what my motivations were when we were doing waste. My motivations are partly to do with the fact that I do believe engineers leave the place that we found in a better place. Architects do it even more and have more control over nature and how we leave nature. And my motivation has always been to make things, not to think and just produce thought and produce knowledge and produce research, but how do you apply that so that the meter can move? And that happens with small innovations in all our projects. And I think that to do that, you have to put yourself in a very uncomfortable position as quickly as you can. So, you know, going to the AA was very uncomfortable. The way I look and, you know, the way I was and who I was dealing with. Same at Harvard. Same when I first met Zaha or Foster's or whoever, you know. It's not a comfortable situation, but that uncomfortableness people get over quickly because we share the ambitions of actually our own discipline and doing something really excellent out of it. So my motivation usually is that. And I don't think engineers should be judged only by what we make stand up. That's the easy part. You do that by the time you're 25, 26. You can make anything stand up. I think we should be judged by who we collaborate with, how we collaborate, and what we do for the next generations of engineers and others. To do any of that, you cannot escape being in academia. You have to have a role in academia, even though academics would not consider me as a scholar, which I'm happy not to be a scholar. I do have an influence on the way some of them even think about what they should be doing. And that motivates me.
So maybe we take some of the questions as well from the public, and then I'll slip in some of mine too. So Alex Felson is asking, thank you for sharing these exciting projects. What is your position on ornament and whether it has a place in architecture through structural engineering?
Alex, the simple answer is yes. And I wish that the discussion hadn't gone tangentially in the last 30 years. I think I have a very strong cultural attachment to ornament. I happen to be a Muslim and I know a lot about Islamic architecture through the work of the Aga Khan. And when I look at the ornamentation in nature, which is sometimes functional and sometimes to disguise something, I do feel that I have a strong alignment with not being purist as an engineer. I get quite often annoyed when architects ask me, how thin can that beam be? How thin can something be? So I'm always nervous about that, saying to them, don't get stuck in that thickness of the thin. Let's talk about how beautiful it might be, or what color it should be, and then we could come back to how big it should be. So my position is that it is relevant, important, and sometimes because of, again, the modernists and the postmodernists, this whole idea of the skin separating from the building, I do feel that it was driven only to the skin. I think you can also bring it back into structural systems. You saw some of that in the pavilion, but there are other projects we've done. You saw some of that in Mazda, where the Mishrabia is built with a very complex ornamented pattern. It's not Islamic, but it is an algorithm that could punch terracotta sheets in a particular way to give shade over time. This was a Foster's idea, not ours, but I think that ornament has a place, and I have written about it, and I'm currently writing about how we can accept and that we could enhance COT by tolerating what the industry says, or not tolerating what they say, which is take it from the factory and make a building. I think you need to apply things to it, and some of them may be ornamental. So I'm all for it. It doesn't have to be purely structure.
Thanks. Another question by Brandon McNiven. Great lecture, thanks. Could you comment on the role of the engineer as a design author, albeit perhaps not design leader, interested in the process of coming up with designs that transcend both disciplines to be greater than what either could come up with alone?
Well, first thing I will say, my position, and that's not to rubbish anybody else's position. My position is that engineer is never the author. We were only born about 120 years ago. Architects have been around for 4,000 years. So there's no way we can claim authorship. That's my first position. Connected to that position is that does not mean we can't contribute a chapter to the book that the architect's trying to develop. And in that arena, you can come up with some inventive ideas that will add to the architecture. So you become kind of a supporting author or editor of his work. I think that there are some engineers who are purists and they do incredible work of research that move materials. And I, for example, John Oxendorff and Philip Bloch, who are both friends, I admire enormously the research they do. But I keep telling them, how many more roofs can you build in the world? Let's do some buildings. Because the minute you apply some of their work to floors, it's difficult. So on the one hand, I think without them, the disciplines will suffer. We will become homogenized and useless. But I also believe that we have to think of the bigger picture as engineers. We mustn't be allowed to come up with a form. That has to come from the history, the place, context, and all the other issues that drive the form.
Maybe we take, oh,
no, sorry, yeah, I was just going to say, so Don has one more question.
Yeah.
So if the AA is a relevant model for architectural education in terms of its speculative pursuits and explorations, what are the schools of engineering that allow for progressive thinking in engineering? So is there a parallel point of focus that we should all know about?
I spoke to our own academics last week, and it was a very unpopular conference for engineering professors. And my answer, Don, is that largely speaking, the answer is no. I think Cambridge and MIT have the best engineering schools in the world, and Imperial probably close to them. I don't know your side of the world, and I don't know China very well. But what I would say is that they don't tolerate what we do, meaning you and we, in that we are practicing and making. A lot of these schools are solving some really important problems, space or algorithms and so on, but they're not into design research. They're into product research, material research, and scientific research, which usually demands a lot of money, and it needs a lot of work. But by the time they've finished, we've built a city. So you and I need to be away from those kind of places. And there aren't many engineering schools that do that. What is happening more and more is engineers are being invited in the conversation, like I was at Harvard, to at least contaminate the dogmatic position of any particular school, whether it's tectonics, geometry, parametrics, whatever, by actually allowing the engineer to say something that architects can't say. And that kind of discussion is not happening in engineering schools. They rarely accept architects as good people or contributing to the value of engineering, rarely. And those that are there are only because they're so awful at practice that they had nothing better to do. They go and teach at engineering schools. So my concern is that there isn't a simple model. And there is space for those models now that we're going asynchronous, and there's space for bringing people together. But you have to start with, what is the question? The question must be, how quickly can we build what the world needs? Not any one particular place, and how can that be applied locally? What discipline can push that? And I think it has to be together, educating new type of designers who are not afraid to get on and build. I'm not saying you don't get historians and theorists. I'm saying that, I'm more on the side of let's get building.
Somebody was pointing at time. I think we are probably having to wrap quite soon. I think there you touch upon something that I was gonna ask, which was basically, there's clearly an interest on interdisciplinarity. I know a lot of the courses that you have taught at Harvard and elsewhere have addressed this issue, and the issue of design research, which I think David was already hinting at the fact that unlike what we might assume engineers might be doing when engaging with CLT, with the waste to energy and other research that I've seen you conducting, of perhaps leaning towards issues of optimization, efficiencies, etc. You always seem to be kind of eyeing for opportunities that lie somehow in between all these disciplines, and that I think in a way, lead to more perhaps novel outcomes or with more relevance towards the city. That's interesting that you've talked a lot about the city as well in your lecture. So I don't know if you want to elaborate a little bit more on the design research and your take on it, because I know it's always certainly sparks lots of discussion, in I guess the institutions that we've crossed paths.
No, I agree. And I really do believe that design research is going to help us get out of the current hole we're in. I always thought it did, even when I was at the AA at the beginning and the whole kind of geometry thing happened and so on. I would encourage anybody who's listening to try and work out a small piece of research in everything you do, because I'm always seeking to not just do what is obvious, because that's been done. I think we all have to be able to do that. But when you're leading or teaching or likely to influence clients and cities and other kids who are going to come up, you have to take a responsibility to do some research. And I do feel that schools that allow that, not only schools as in education, but practice that allow a lot of architects have their own in-house research bits they invest in. Those areas, I think, are where discipline and profession will come back together, hopefully for a better output as when you sum these two up. Otherwise, the risk we face really is, and a lot of people are talking about it, is that the profession fades into more and more being irrelevant, and you go to places like Shenzhen where everything looks the same. It's beautiful, but everything looks the same, feels the same, will be the same, and they will knock it down in 20 years and rebuild. So if we don't do this research and find novelty, interest, or even find ways of people disliking something we did to generate an emotion in the society, which is common people who now understand design better, you can't do that without doing some research and taking speculative decisions and educating. Well, while you're educating, you also need to put your hand in on trying to make some things.
Right. Well, thank you very much, Hanif. I think the time's come up, and I think we very much appreciate your presentation and a chance to talk. And I think everybody's enjoyed very much the chance to kind of ask you questions and get your feedback and hear from you. So I think we will wrap up here, and we just need to make some announcements about the upcoming MSD at Home events. Actually, coming up tomorrow will be William Smart from Smart Design Studio, and that will be hosted by Alan Pert. And on Tuesday, the 29th of September at 6 o'clock, Su Sheng Han will be talking, and that will be hosted by Professor Donald Bates. And I think on Wednesday, the 30th of September, there will be a book launch by Anoa Pieris, hosted by Paul Walker, on her book, Sovereignty, Space, and Civil War in Sri Lanka. So just want to say thank you very much.
Yes. Thank you very much, Hanif. It was great having you tonight.
Thank
you
Hanif,
for having me. I apologize for the videos, but I hope it didn't make too much difference.
It was great. I mean, I know having the videos is always nice, but it was perfect.
Okay.
Thank you very much.
Go soon. Bye.
Bye.
Bye. Thank you.